Hello everyone and welcome back to the channel. Today we're diving into one of the most exciting space missions of our time, NASA's launch of the Europa Clipper spacecraft. This mission is heading for Jupiter's intriguing moon, Europa, a place that could potentially harbor signs of life. Yes, you heard that right. If you've ever wondered whether life exists beyond Earth, then you'll want to stick around because this mission might bring us closer to answering that age-old question. Let's break down what makes the Europa Clipper mission so important, what scientists hope to discover, and how this spacecraft will explore one of the most mysterious moons in our solar system. Europa, one of Jupiter's 79 known moons, is unlike any other. It's about the size of Earth's moon but covered entirely in a thick layer of ice which hides a massive subsurface ocean beneath its frozen crust. In fact, scientists estimate that Europa's ocean could contain twice as much water as all of Earth's oceans combined. This enormous body of water makes Europa one of the most promising locations in our solar system to search for extraterrestrial life. The possibility that life could exist beneath its icy surface is what drives this mission, and the Europa Clipper will play a crucial role in unlocking the secrets of this distant world. The Europa Clipper spacecraft is loaded with a suite of sophisticated instruments designed to study Europa's surface and its subsurface environment in incredible detail. Equipped with cameras, radar magnetometers, spectrometers, and ice-penetrating radar, the spacecraft will collect data to map Europa's icy shell, analyze its surface composition, and even probe the subsurface ocean. The ice-penetrating radar in particular will be used to determine the thickness of Europa's ice crust and identify any subsurface lakes that might exist within the shell itself. These tools will also help scientists look for signs of plumes, jets of water vapor that may be erupting from Europa's ocean through cracks in the ice, much like geysers on Earth. If plumes are detected, they could be sampled to search for organic molecules, the building blocks of life. Getting to Europa is no simple feat. The spacecraft is embarking on a journey of over 2.8 billion kilometers, taking approximately 5 years to reach its destination. But once it arrives in the Jupiter system, the Europa Clipper won't just orbit the moon. Instead, it will perform a series of 50 flybys over the course of its mission, allowing it to observe Europa from a variety of angles. These flybys, some as close as 25 kilometers above the surface, will help minimize exposure to Jupiter's intense radiation while still gathering critical data. Each close encounter will allow scientists to gradually build a detailed map of the moon's surface, pinpointing regions that could be of interest for future lander missions. The main goal of the Europa Clipper mission is to understand Europa's habitability, whether its ocean possesses the chemical ingredients and energy sources necessary for life as we know it. The spacecraft will also look for evidence of hydrothermal activity on the ocean floor, where hot water and minerals may mix, providing the necessary conditions for life. Such hydrothermal vents exist on Earth's ocean floor, and they are known to support thriving ecosystems even in the complete absence of sunlight. If similar conditions exist on Europa, it could significantly increase the chances of finding life beneath the ice. This mission is also a technological marvel. To withstand the harsh radiation environment around Jupiter, the spacecraft is equipped with radiation-resistant electronics and protective shielding. It uses solar panels for power, a challenging choice given that sunlight is about 25 times weaker at Jupiter than on Earth. These massive solar arrays are among the largest ever designed for an interplanetary mission, allowing the spacecraft to generate enough energy to keep its instruments running throughout its lengthy journey and mission duration. One of the most interesting aspects of the Europa Clipper is that it's not designed to detect life directly, but rather to gather the evidence that could point us in the right direction. By studying the moon's surface composition, measuring the thickness of the ice, and searching for organic molecules in the water plumes, the Europa Clipper will provide a wealth of data to help determine if life could exist on Europa. If signs of habitability are found, future missions may focus on landing on Europa to search directly for evidence of microbial life. The entire mission will span at least 4 years of active data collection once the spacecraft arrives at Jupiter, with the potential for mission extensions if everything goes smoothly. The data gathered could fundamentally change our understanding of the solar system and the potential for life beyond Earth, making the Europa Clipper one of NASA's most ambitious and potentially groundbreaking endeavors. It's not just about finding life on another moon. It's about expanding our understanding of the conditions that make life possible and reshaping our place in the universe.